Hi, I'm Nikita. I'm on the Glee team for communications.
Hi, I'm Matt. I'm on the Glee team for software.
And today we're going to be talking about the temperature sensor code.
So as an overview of the code we will be using the temperature basic example sketch, which you can find by going to File, Examples, Glee 2023, Module Sketches, Module 4 Temperature Sensor. What the sketch is doing is that is reading the temperature of the temperature sensor and then printing it out to our serial monitor. It also takes into account the time to take these measurements, and it also has the capability of converting from Celsius to Fahrenheit.
So, what are some libraries that we should include in this sketch?
So we always want to include necessary libraries so that we can have all the functionality we need to interact with our sensors. In this case, for the TMP117 sensor, we want to include 3 libraries. We want to include the Arduino library for Arduino functionality. We want to include the Glee sensor library for Glee sensor functionality. And finally, we want to include the TMP117 library, which includes functionality specific to the temperature sensor. So after we include our libraries, we want to initialize objects, and we want to specifically initialize a temperature sensor object. So to do this, we write TMP117 sensor name, and then in parentheses, ID false. So in those parentheses, we have something called arguments, which is basically us setting the attributes of our TMP117 object. In this case, the first argument is ID, which is an integer or whole number that we're setting for the ID of our sensor. In our code, we are just using 1. The second argument is just false, which is we're telling the debug mode to be turned off. If we wanted the debug mode to be turned on, we would put true instead. But we are not doing that here. We are just putting false so that the debug mode is turned off. So we initialize our object with these arguments, and then we give it a unique name such as thermometer. Next, we want to include our variable definitions. To do so, we write in the format variable type, variable name. Here we are using 1 integer and 4 floats variables. The integer, again, is like a whole number, like 1 or -2, but a float is a decimal number, like 1.0 or 2.0. So here we have a variable called time between sample, which will represent the time between samples in milliseconds, and that will be, again, a whole number. And then we have 4 float variables, 2 for representing our temperature in Celsius and Fahrenheit, and 2 for representing the start and end time of our measurements.
So, how would we start setting up our code?
So in our setup function, we have the usual serial.begin function, but we also are assigning a value to our time between sample variable. Here we are setting it to the value 1000, which represents 1000 milliseconds or 1 second. And basically this means we want our sample rate to be 1 sample per second. So if we then look at our loop function line by line, our first line is another variable assignment, but here we are setting it to a function call. The millis function is getting the number of milliseconds that have elapsed since the program started executing. So here we want our start time to be equal to the number of milliseconds since the program first started running. Next, we have our function calls for get temperature C and get temperature F. So here we're actually getting data from our temperature sensor and we're storing it in the appropriate variables, temperature C and temperature F. And to use a function associated with our object, we write the unique name of our object, which in this case is thermometer, followed by a dot, followed by the function name. Next, we actually output the data that we have gotten by using a series of serial.print and serial.println statements. So we are printing out the temperature in both Celsius and Fahrenheit. Next, just like with the start time variable, we want to set our end time variable again to the millis function, which has since changed in value because more milliseconds have elapsed since that it has been first called. Now, finally, as we talked about before, we want our sample rate to be 1 sample per second, But we can't do that just by delaying our sketch by a constant number of milliseconds, because the time to get our measurements might change each time we call our functions. So in order to make sure that we keep the same sample rate, we want to subtract the time it took to get our measurement from the time between sample. So in this case, we are subtracting the end time from the start time, and then taking that difference and subtracting it from time between sample, which in this case is 1,000 milliseconds.